Hi, you're welcome to another tutorial. So in this lesson, we're going to look at linear equations. So when we say linear equations, we're looking at equations in which the variable is of the degree 1. That means that the highest power of the variable is going to be 1. So let's take an example. So linear equation can be in the form, let's say 2x plus 3 is equal to, let's say, 12. The reason why it's a linear equation is because this is our variable and the degree is 1. So if it was a square or a cube, we would say it's not a linear equation. So we're going to look at how to solve questions like this. Now, to solve questions like this, all that we need to do is to take 3 from both sides. So that is grouping of like terms. So when I take 3 from here and I take 3 from here, what I'm left with is that this cancels that, and I'm left with 2x. 2x is equal to 12 minus 3, that gives you 9. Then we divide both sides by 2, and we say x is equal to 9 on 2. Or in mixed fraction, we're going to say 4 whole number 1 over 2. So this becomes the answer. But we're going to look at more complex ones, not simple questions like this. So if this is a beginner, if you are a beginner and you want a beginner-friendly questions, you can put that in the comment section. I'll gladly assist you. But if you want more advanced version, then I think you can stick around and then see the different ones that I have. So let's take the first one I have from here, which is 5 into brackets x minus 2. That's is equal to 3 into brackets x plus 4. So this is my first question that's going to solve. Hope you can see. So with this question, the first thing we're going to do is to expand the brackets. So to expand the brackets, we're going to multiply the 5 by this. Then we multiply the 5 also by the second term. Come here, then the 3 also multiplies the first term, then the second term inside the bracket. So what do we get? When we multiply 5 by x, we get 5x. Multiply 5 by negative 2, we get negative 10. Then we multiply 3 by x, we get 3x. Then 4 times 3 is 12. Alright, so from here we can also group like terms. Either you add 10 to both sides and you take away 3 from both sides. So if we do that, we're going to group like terms, all the variables on the left and then the numbers on the right. So we can get 5x minus 3x, because here is positive. So when it crosses the equal to sign, it becomes a negative number. Positive 12, and then because the 10 is negative, when it crosses the equal to sign, it becomes positive 10. So to simplify this, 5x minus 3x gives us 2x. Then 12 plus 10 gives us 22. So x is going to give us 22 divided by what? 2. And our x becomes 11. So this becomes the solution to the first problem. So let's look at another problem, okay, quickly. Let's take this second question. So with this question, it's they're in fraction form. So you can see the denominators as 4 and then 3. Okay. If you get a question like this, where we have a fraction in it or a radical in it, what we have to do is to find the LCM and multiply each term by the LCM. So here, our LCM is 12. That's the LCM of 4 and then 3. That's 12. So from here, we can multiply each term by the LCM. So we take the 12, multiply by the first term, which is x plus 2 all over 4. Then we multiply the 12 also by the x minus 1 all over 12. Also multiply the 12 also by the constant here, which is the 1. So 4 will go into itself 1 and go here 3 times. Here it's supposed to be 3. So 3 will go into itself 1 and go here 4 times. Right. So to expand this, what we do is that the 3 is going to multiply both the x plus the 2, all of that. Then the 4 also multiplies the x minus 1. And 12 times 1 is 12. Alright, so we're done with the first part. Now, just as we did in the previous example, all that we need to do is to do the expansion. So this multiplies that. Then this also multiplies that. this multiplies this, like that. We expand the bracket. So let me just do this. So 4 multiply x and I get 4x. Sorry, 3x. 3 multiply x and I get 3x. Then 3 multiplies 2 and I get 6. 4 multiplies x and I get 4x. Then 4 multiplies 1 I get, because it's negative 4 multiplying negative 1, so I get positive 4, then 12. Right, so we can group like terms. So this and this can combine. Then we combine this and that. So if we combine this and this, we get negative x. So we get negative x. Then when we combine this and this, we get positive 10. Then 12. Hope you get it. Then the next thing is that we're going to group like terms, that we take 10 from both sides. So take away 10 from here, take away 10 from here. So what's going to be left? We still have our negative, because this is going to cancel that. So we're going to have our negative x, and we're going to get that's positive 2 here. So our x becomes negative 2. That becomes the solution to this problem. I hope you can see. All right. So let's move on to another example. So we have the next question here. This is our next question. So we have the next question here. So with this question, there's no fraction, so we don't need to find LCM. But you can see that we have a factor outside the bracket. So it means that we just have to expand the bracket first. Then we see what to do. So let's first expand the bracket. So this 2 multiplies the first term, multiplies the second term. This 3 multiplies the first term and then the second term. It doesn't affect the negative x. It's a different term altogether. This is also a different term. So we're going to have 2 multiply 3x and we get 6x. Then 2 multiplies negative 4 and we get negative 8. Then we have minus x is equal to, then 3 multiplies x and we get 3x. 3 multiplies 2, then we get 6 and plus 1. Now we can solve this because they're the same term. We can also operate on this and this. Okay, so this and this gives us 5x. Right, that's 6x minus x gives us 5x. Then we have negative 8. Then this and this gives us 7. So we have 3x plus 7. Then we can take away, we can add 8 here because it's subtracting, so we can get rid of it. Then we take away 7 from here. Or we can just do grouping of like terms. So it's the same thing. Alright, so let's say 5x. Then we take away 3 from here. This 3 moves here. So we get negative 3x. Then 7. Then plus the 8. Alright. So this 8 moves to this side, becomes a positive number. The 3x moves to the side and becomes a negative number because it's positive here. So 5x minus 3x, that gives us 2x. Then 7 plus 8 gives us what? That's 15. So we divide both sides by the coefficient of the variable every time. So that gives us 15 on 2. But you can decide to change the answer to mixed fraction. That should give you 7 whole number. That's going to be 1 on 2. That's it. So this becomes the solution to this problem. I believe this is not too complicated, but we have another one that's a little bit longer than the previous one, so you can stick around and check that one too out. Let's look at the next question. So this is our next question. It's a fractional. They are fractions. Just as we did in the previous example, what we're going to do is to find the LCM as usual. So the LCM is 20, which we've done that. Then we multiply each term by the LCM. So we take the 20 and multiply by the first term, which is 2x minus 3 all over 5. That's the first term. Then we take the 20 also and multiply by the second term, which is x plus 1 all over 2. Then we take 20 multiplied by the last term. The previous one, we had a constant. Yes, so it was quite easier to work with, but this one, there's a fraction that we need to work with. So here we have 5 going into 20 4 times, 2 going into 20 10 times, and then 4 going into 20 5 times. Because there are fractions in it. Whenever you multiply through by the LCM, the denominator will be able to cancel out the um, LCM. So every time do that. Okay. Then whatever you get here, take it and then multiply by the terms we have here. Then we have 10 also multiplying the x plus 1. Then we have the 5 multiplying the 3x plus 4. Sometimes when I get to this point, you can pause the video, then you try to solve it, and then you see if you can solve it or not. Okay, pause the video and then you try your hands on it. Then you compare your answer to mine to see if it's the same. All right, so let's go. We will have one more question to go. I'm solving 5 questions in all. So when we are done with this one, we have one more question to solve. So you should continue to stick around. Don't click away. All right, so we have 4 multiplying 2x and we get 8x, and this multiplies that and we get 12. Then we have 10x, then we have 10, then we have 15x, then we have 20. We group like terms and we solve. So this and this can give us 18x, right? So that's 18x. Then this and this can give us negative 2. Then this one just maintain. Then we can group like terms. That's we take away negative 15. We take away 15x from here. Then we add 2 here. We add 2 here. So this is what I mean. So you're going to add 2 here so that cancels. And whatever we do to the left, we do the same thing to the right. And we take away 15x from here. We take away 15x from here. Hope you understand. So that 18x minus 15x will give us 3x, and this cancels that. This also cancels this, and then 20 plus 2 gives us 22. We divide both sides by 3, and then we see that our x becomes 22 over 3, right? So you then you need to mix fraction if you want to. So we're done. Let's take the last question quickly, and then we are done. So this is our last question, our last and final question to solve under linear equations. So let's take a look at this one. So with this question, you can see that there are multiple brackets in it. So we're going to see how to go about the question that looks complicated like this. So first, we have to expand the smaller bracket inside before we come and expand the outside bracket. So what I'm trying to say is that we need to expand brackets inside like this before we come and expand the bracket that's outside here. We expand these brackets because this is the number outside, that's the common factor which has been factored out here. So we need to expand this. And when we are done, we take this outside factor and use it to operate on all of them or multiply by every 10 inside. So let's see. So I'm going to maintain this. Please, you can pause the video and then try your hands on it to see if you can solve it. That's the beauty about math. If you don't try it, you think that you understand it, but when you start, realize that no, it's not something that is easy that you think you can do. So you try it out and then compare your answer to mine to see if it's correct. If you make any mistake or you think I am wrong, you just drop a comment and then I will assist you with the explanation. So we're going to expand that and we get 3, 2 is 6, and then 3 times x is negative 3x. Okay, so this is what we have. Then we can see that now we can expand even further. So we multiply the 3 by the 2x and we get 6x. Then 3 by x, we get 3x. Then 3 by 4, we get 12. Then we get 2x. Then we get 12. Then 6x. Then we can operate on this and that. That should give us 3x plus 12. Then we can solve this and that. That should give us negative 4x. And then we have that. So from here, as usual, we group like terms, or we subtract 12 from here and then add 4x here. But don't forget that because you took away 12 from here, you need to add the 12 here. And because you added 4x here, you need to add 4x here. Hope you get that. So when you solve it, you're going to get this one canceling that, and this gives you 7x. Okay, and this cancels that, and 12 plus 12 is 24. All right, so we divide both side by 7, both side by 7, and then our x becomes 24 divided by our 7. All right, so that becomes the answer. Very simple as that.
Okay, I just realized that there's an error in the solution, because if we are taking away 12 from here, we need to subtract 12 from here, not add. So that's the error. So that when we have positive 12 minus negative minus 12 becomes 0. So it means that this is supposed to be 0. You, you get it? If that's the case, 0 divided by 7, that should not give us this. That should give us x to be equal to 0, because any number divided by 0 divided by any number, that gives you 0. So this becomes the solution, not this. This is wrong. All right.